This is Craig Migliaccio from acservicetech, and today we're going over gas furnace error codes. So we're going over the status code light on a gas furnace and what that means on Carrier, Bryant, and Payne furnaces. You can use this information basically on any gas furnace because the sequence of operation of a furnace is very similar regardless of the manufacturer. When approaching a gas furnace that's not functioning, we can remove this top door, and on other models you can remove the large front door, but we're going to leave this lower door in place because it's holding a door switch and it's going to keep power to the furnace control board so you don't lose your status code light. Now, of course, you could recall your status code light with your service pamphlet right here. And so inside this pamphlet, there's also going to be a legend for the status codes to tell you what the error means, so what the problem is on the gas furnace. Now, you're also going to have to do troubleshooting because it's only going to point you in the direction of the possible problem. We're going to start from the top down. And so with the LED code, when we have continuous off, that means that there's no LED light here, and so we don't have power to the furnace, or we don't have power to or out of the transformer. So I'm going to show some of the test points for measuring that. If we think we have power onto the furnace and there's still not an LED status code light, what we can do is take our measurements right up here for voltage and alternating current, and we see that we're measuring 0 volts. Now, the other thing is we want to close the door switch if we're going to measure down here. Of course, we've already measured their 0 volts, so that means that anything upstream of it is going to be the problem and not downstream. If we measured 120 volts here, then we could close the door switch and then come down here to the L1 and common neutral bar and measure down here. And so we can measure from point A to point B, and as you can see right now, we have 0 volts, and so that's L1 in common. If we did have voltage right here, we would then need to go to the primary in common. And once again, we have 0 volts because the primary in common is heading over to the transformer, and basically we want to see if this is getting fed with 120 volts of power. And the other thing is we can measure the 24 volts by just taking our probes right here into the ends. Now, we're not sticking them right into the spade terminals, we're sticking them between the plastic and the spades. And so with our power right here, we want to see if we're measuring 24 volts. So we either don't have power to the furnace, or we have maybe a loose connection down here, or we have a bad transformer. And so basically you just pick a point, which is, this is the starting point up here. So we knew that we have a problem in this case upstream, so before the furnace. But if we did have power here and we did have power at the door switch, we had power down here, we would then go starting to move over to the transformer to see what the problem is. Maybe the transformer has been burnt out. If your status code light is solid and you do have power to the furnace, then that means that basically it's just on standby mode, just waiting for a call for heat to turn on. But if you think that you have a call for heat to turn on, such as on a thermostat like this, you've turned it to heat, you've turned the temperature up, nothing's happening, then we have to investigate further in the lower compartment. And so we can remove that door. We want to close the door switch with a magnet or tape. And we're going to have our multimeter set on voltage. So we're going to measure our voltage for alternating current. And so basically, right here is the thermostat wires. We should have a call on W in order to turn on. So we can measure between common and W, and we should have 24 volts if the thermostat is telling the heat to turn on. So the heat should be running right now if we have this set at, say, 76, and it says heat on, and 73 degrees is what it is in the building. It's obviously not connecting the R and the W inside the thermostat. Now, between R and common, you can see you have 27 volts. So if R and W were touching in the thermostat, then we would have a 24 volt signal on the W, and you see right now we don't. So that means that your problem would be in your thermostat wire. If you are trying to turn the heat on and just nothing's happening and you're not getting a signal to turn on. On a Carrier, Bryant, and Payne furnace, a rapid LED flashing light means that the polarity is reversed. So the hot and common are switched, either at the circuit board, right here at the electrical connection, or at the power supply to the furnace. So make sure to turn the power off in order to correct that problem. With the cover off and our door switch closed, we have a rapid flashing light indicating that our electrical polarity between the black hot wire and the white common wire are reversed. In fact, we're actually measuring 120 volts between our common and our ground, and we should be reading 0 volts. And even if we were to open up this door switch, we're still measuring voltage down here because we somehow have a power onto this common wire, and that's no good. So this should be reading 0 volts right now, and with the power on, and so with the power off to the furnace, we would need to identify where the problem is. For the remainder of this video, I'm going to remove this door and leave it off, and I'm going to use my magnet to cover over the door switch as we cover each of these LED status code numbers. And so status code number 11 is simply that if you were to recall the errors, then it means that there is no errors in the last 72 hours on this particular unit. So you're rarely going to see number 11, but number 12 is going to be blower on after power up. So what that means is if you have a call for your heat to turn on and then you shut off the power to the system and then turned it back on, then the blower motor is going to run for a specific amount of time, and it's doing that to cool down the heat exchanger back here so the furnace doesn't overheat. So if you were just running this and the gas was ignited and basically you're heating and you just turn the power off, it wants to first cool the heat exchanger down before the furnace operates its sequence of operation and reignites the gas. So we're going to show you that now. So you're going to have your first light is going to be a short flash, and your second light is going to be longer flashes, indicating a number 12 error code. So we're going to have 1 short flash, 2 long flashes. Now after that blower motor stops running, after it's 90 seconds, what's going to happen is if you have a 24 volt signal between W and common, that means that the sequence of operation is going to turn on. And so for the rest of this video, what I'm going to do is I'm going to disconnect power to the blower motor so we don't have to hear that noise running. So you see we have 27 volts, and so right now the fan motor should be running, but I have that disconnected right now, and so the first thing that would turn on after the blower motor ran for 90 seconds is the inducer motor would turn on first, the pressure switch would prove that this is running, the hot surface igniter would turn cherry red, the gas valve would open allowing the gas to flow through, and then we would have the flame rod proving the flame rectification process. Then after the heat exchanger warms up for about 45 seconds, then the circuit board is going to turn the fan on, and that would be how this furnace operates. Now let's move on to the next one. Status code light number 13 is a limit circuit lockout, and that means that this furnace is going to not operate for say 3 hours, and then it's going to check again to see if the flame rollout switches or the thermal limit switch is now closed. And so basically it's going to go down to error code number 33 now, which is a limit circuit fault. And here's the thing, with a gas furnace, if you have a call for heat on the W right here for your thermostat wire, and you have 24 volts there, the thing is that the furnace, before it's even going to turn this inducer motor on, it's always checking to see if a limit switch is tripped. It's checking for that, it's checking for flame rectification, it's checking to make sure that the pressure switches are open. It's doing these checks before it even tries to turn on. So this error code number 33 could then happen while the system is running. And it could also happen, say, if the furnace is off and it's showing you that there's a problem with one of your limit circuits, such as thermal limit or flame rollout switches. So what we do is if we were to turn the power off and turn it back on, you're going to see a number 33 error code. So 3 short flashes, 3 long flashes. Now with a status code light of 33 or 13 indicating a problem with a limit switch, we can just check from the common, so make sure you can see that, to this red wire right here, and you can see we have 27 volts present there, and we have 0 voltage right here. Now you can see these red wires right here, we have red wires up here at these switches right here. So that's a flame rollout switch, and behind this gas valve is a thermal limit switch that's inserted behind the into the heat exchanger area basically. And so let's get another shot at that so you can see, and I'll show you how to test up here. So right back here we have a flame rollout switch and another flame rollout switch, and that is if the flame back here is popping towards the front. And it should never do that, because if you have a crack in the heat exchanger, maybe it would allow the blower motor to push the air through the heat exchanger and pop back over here. That would be a very serious problem, and that's why these flame rollout switches do not auto reset. it has a manual button on it that has to be reset when the technician gets there in order to determine what the problem actually is. And so it's a major safety concern, so you don't want to reset those. Now back here, that is a thermal limit switch, and that will open up if the heat exchanger area back here warms up too much. So basically, if you have a low blower speed, that will be a problem. So if you either have a bad blower motor or a low blower speed, and eventually the heat exchanger just gets too hot back here, and that switch is going to open up the electrical circuit, and it's not going to have 24 volts down at the circuit board, and so that would be the issue. But that one, once again, automatically resets, and the temperature measurements are on here, right here. So it says L205 minus 20 degrees, and so if it gets up past 205 degrees, it's going to open up, and it will close back down once it gets down to, say, 185, because you take 205 minus 20 and you're at 185 degrees, that's when it's going to close again. And so basically, if you don't know which one the problem is, you can place your 1 multimeter probe here, and then basically you can just chase them around. So you're going to take your other probe, you got 27 volts there, 27 volts there, 27 volts there, 27 volts there, and say we measured over here and you have 0 volts. Well, that would mean that this is the switch that tripped. So you know that you have a flame rollout problem versus a thermal limit problem. And a thermal limit problem, you definitely want to be taking temperature measurements across the furnace. With a flame rollout situation, you want to do a combustion analysis. You want to look for the possibility of a cracked heat exchanger. And so you just want to determine why they're tripping. It doesn't mean that the switch itself is bad. These are just safety devices. So you make sure to never jump across there and just leave that. That will be only for maybe testing purposes. But these safety switches are what's going to guard this furnace and the building owner from any hazard. Now this thermal limit switch back here could trip due to something simple, such as maybe a filter is not changed and the filter is completely dirty and clogged shut, so there's no airflow across the heat exchanger area. Or maybe a flex duct in the return has collapsed on itself. So it could be a simple reason why these are tripping, but the flame rollout switches are typically a more complicated or more dangerous situation. Caution should be taken either way. Status code light number 14 with 1 short flash and 4 long flashes indicates an ignition lockout. And that means that this furnace tried to ignite the gas 3 times before it went into this ignition lockout. And so this indicates number 34, the ignition proving failure. And there's a lot of different issues that could be at play with that. And so you could have something as simple as this right here, where you have this switch in the off position, it needs to be turned on. You could have your gas valve, it could be shut off and it needs to be turned on. You could have maybe your natural gas or your propane off outside, so at the meter. So that could be an issue. We could have a flame proving signal when we're trying to measure our microamps and direct current. So that's a flame proving process, which we'll go ahead and measure with our multimeter in series. And we have a whole nother video on flame rectification. There could be an issue there. We could be not getting a signal of 24 volts to the gas valve. We could be not supplying enough gas pressure at the outlet of the gas valve, or we could not have the correct pressure on the inlet of the gas valve. So the gas valve could also be bad. There's a lot of different issues that could be at play right here. And so what we'll do is we'll reset this and we'll make sure that this is now on, and we'll take you through the ignition process, measuring microamps, and we're measuring our outlet pressure. Now we're going to take you through the ignition process. What I'm going to do is I'm going to turn the power off and turn it back on at the door switch. Now when I turn it back on, there would normally be a 90-second time where the blower motor is going to be running in order to, say, cool off the heat exchanger, but in this case, we're just going to skip ahead and to where the inducer motor turns on. So here we have our inducer motor turning on first. Our pressure switch is going to close its internal electrical connection, and then after that you're going to see the hot surface igniter turn cherry red. Now the hot surface igniter could also be a problem because maybe that's cracked, and so we have a whole nother video on testing hot surface igniters, linked down in the description section below. But you can see it's turning cherry red right now. Another thing could be, say, this ground wire. You could have a loose ground wire or a problem with your ground on the furnace, which could affect this right here, which is your flame rectification signal. So right now our outlet gas pressure, which is measured over here, is 10.5 inches of water column, and that's basically correct for a single stage gas valve. Now over here we're measuring 4.2 DC microamps. And now our blower motor would normally be running, but we have that shut off right now, so that's what should be happening. So your fan motor should be running and basically just blowing the air across that hot heat exchanger. So if the ignition is not proven for 3 times, so the hot source igniter would have to turn cherry red 3 times, and if it does not ignite the gas or doesn't prove the flame after being lit, then what's going to happen is the furnace is going to end up into the ignition lockout, which is the number 14. And so this right here is a flame rod that has corrosion, and actually it was overheated and maybe bent. So this could be the problem. It might need to be cleaned, or in this case it needs to be replaced. But you want to have a good DC microamp signal, and so we measured about 4, and basically anywhere from say 2 to 10. Really, you want to be closer into say 3 or 4, and so that is a good signal. But if you were lower than say 1, you know you have a problem. It could be with the ground wire, or it could be with the flame rod or the flame itself. And basically, it's converting an alternating current signal on this wire into a direct current signal that's measured on the ground frame of the furnace, and it's measured at the circuit board down here. But if you want to learn more about that, make sure to check out the other video we have on flame rectification in the description section below. On this furnace, error code of 21, which is 2 short flashes, 1 long flash, means that the gas valve, there's something wrong with the gas valve. Of course, you can measure your voltage with a multimeter to make sure that you're getting 24 volts right over here at the gas valve, but maybe something on the inside has shorted together, and so basically the control board is throwing a number 21 signal saying that the gas valve may need to be replaced. But we're not going to be able to show that error code on this one, so I just wanted to describe it. Number 22 is a abnormal flame proving signal, which means that there is still a flame up here even when there's no call for heat to turn on. So maybe the thermostat got satisfied, the sequence of operation for heat has stopped, but the problem is this gas valve is internally stuck open, allowing gas to continue to flow through. And so the furnace is measuring a flame rectification signal, say 4 microamps, and so that will be a problem. But in this case, obviously, we don't measure anything right here, so we have no flame rectification signal. We don't have any gas flowing through here presently, so we're good right now. But I just want to show you this furnace is always monitoring for a flame rectification signal to see if there's a flame even without a call for heat. So I'm just going to put this right here. So on this wire, which connects to the flame rod, we're measuring, say, 98 volts. And so it's always going to be live anytime there's power on to the furnace. So that's just a safety to make sure that there is no flame up here when there should not be. Status code light 23 means that the pressure switch is stuck in the electrically closed position, meaning that the switch is closed, which would normally prove that this is running, but the fact of the matter is it's not running, so it should be open. It should be opened up until this inducer motor creates a differential pressure, which is measured on the pressure switch over here. And so let me just show you what that looks like. So if we have a problem, we're just going to put one on the ground, one probe on the ground. We're going to measure for voltage and alternating current. It's going to be a 24 volt signal. So we're measuring, so anything between say 24 and 29.5 volts is considered 24 volts. So we're measuring 27 volts there. And I'm going to go on the lower tab, and we also still have 27 volts. That means that that switch is electrically closed. It shouldn't be. So let me show you what you should be measuring. So right now, you see, once I remove the jumper from down there, we now have this switch is closed right here, but that's because the inducer motor is running. What we've done now is disconnect our inducer motor, and so what I want to do is show you what it should be measuring. And so with the inducer motor off, you see we're measuring 27 volts on one side, and on the other side we're measuring 0 because that switch should be open. And it is right now. In this case, if you have a pressure switch that is stuck in the closed position with the inducer motor off, you either have a problem like a blockage in your tubing that's locked in this, say, lower pressure in the pressure switch, or what's more likely is the pressure switch is bad. And so that pressure switch would need to be replaced with one of the same inch water column value, and this one right here is a 0.68 inches of water column value. It's also important to note that pressure switches rarely go bad. It's typically something else that's causing the problem, but with this specific error code, it most likely is the pressure switch. But we're going to be moving on to some other error codes that have to do with the pressure switch monitoring for safety. Error code number 24 indicates that you have a blown low voltage fuse. And so if you can see that right there, it's a burn mark right in the middle of it. And what that means is that the R wire, the thermostat wire, is shorted up against either the common or part of the ground frame. And it may be shorted against the ground frame maybe after going through one of the other wires, say if you're calling for the fan to turn on or heat or air conditioning. But basically we have a whole nother video on how to find low voltage shorts down in the description section below, but you use your multimeter with electrical resistance in order to determine where the problem is. You don't just keep putting in fuse after fuse and watching them blow. So you have to really diagnose that with your multimeter. Error code status light 31 and 32 have to do with these pressure switches. And so this is a high pressure switch in the front and a low pressure switch in the back. Some of these gas furnaces that only have a single stage gas valve may have two pressure switches. And one may be measuring straight to the inducer motor, and one may be measuring over to the condensate trap. And so regardless of whether it's a 31 or a 32, basically the long and short is that the circuit board down here never got a signal back saying like a closed circuit, meaning like the inducer motor is not running when it should be. So right now we have a call for heat, we've got 24 volts on the W, this inducer motor should be running right now. And if it were running, then this pressure switch should close. So both of them should close, the one in the back and the one in the front. And so in this case, number 31 has to do with this high pressure switch, 32 has to do with the low pressure switch in the back. And so we can measure right here. So we got 27 volts there, and we have a no voltage right there, indicating that that electrical switch is open. So right now we know we have a problem with the inducer motor because it's not running. And so if it was running, such as right now, and we still have the same problem, 27 volts there, and then we have no voltage there, well, we know that we're not measuring the pressure on the pressure switch. It would be a negative pressure compared to atmospheric pressure. And right now we know because we have this tube disconnected right here. And the issue could be that you have a tube problem. Maybe it's I've seen them decomposed basically. I've seen them blocked on the inside. I've seen also, if this has a metal inducer motor housing, I've seen the little hole is clogged. And so it could be corroded and clogged. There could be multiple different reasons why these pressure switches are not closing. There could be a combustion air problem where it's blocked. You know, it could be an exhaust problem where that's blocked. So there could be many different issues. The exhaust, maybe secondary heat exchanger, that could be clogged. There could be several reasons why this is not closing. And so this is a safety switch, and you would never want to bypass that ever. You want to make sure to find what the problem is. Now, just because this is not closing, even with this tube connected, it does not mean that the pressure switch is the problem here. And so you could take another instrument in order to test this outside of the furnace, you know, a different manometer that has a pump on it. You could have another issue such as back here, there is a condensate trap, and that could be the problem. That could just be clogged with water. You want to think of the simplest things first. And so it has a drain that drains down. You could take a shop vac down here and suck that through. You know, you'd want to do that with these tubes disconnected from the pressure switch because you don't want to damage a pressure switch with too much of a pressure differential. But you could take this trap out, you could rinse it out, you could clean it. There could be several reasons that this is not closing. Now, one thing I want to point out is on this furnace, we're equipped with a low pressure gas switch, and that means that this has been converted to propane because it's LP. So right here, this is protecting the furnace in case you have low pressure at the outdoor propane tank, because you don't want a low pressure on the outlet because you'd have like an intermittent kind of flame, or just it would not be correct. And so that would be a problem. So this right here, this could be opened up right now, and so that could be the issue and maybe not the pressure switch. So I've seen these installed on limit switches, so basically in series breaking the limit switch wires, or on the pressure switches like this, so you want to be aware of that. Now another thing could be that if just because this is not spinning, it doesn't mean that the inducer motor is bad. You want to make sure that you have the proper power supplying the inducer motor, and some inducer motors require a capacitor. So this one right here has a small black capacitor, but some inducer motors are shaded pole and they do not require a capacitor. Some look like this little black box, and some are using those like aluminum capacitors. And so you could replace this with an aluminum one as long as it has the same microfarad reading. And so a higher voltage and the same microfarad reading, so you could replace this one with one of those. But you just want to make sure, if you don't know the microfarad rating, you typically can see it on the rating plate of the inducer motor itself. So the other thing is, on the inside of this inducer motor, there could be some broken blades on the inside of here. Some of the plastic blades may have sheared off. You could have a problem where you have excessive wind blocking the exhaust. There's a lot of things to play in here, and so you want to test each one and visually inspect each one so that you can determine what the problem is. But we're typically starting here with our multimeter, and we're also using a water column manometer, so we can tee in here in order to measure our inducer motor's applied pressure. So let me show you that. So now we have our water column manometer teed in right here, and we're also going to take our voltage measurement on the pressure switch just to show that it is proving that the inducer motor is running. So we're going to go ahead and turn that on, and we're going to skip past the time where the blower would need to run for 90 seconds. So you can see that the inducer motor is applying 1.53 inches of water column against that pressure switch, which is only rated at 0.68. So we know that it's good and everything's operating correctly. Let's measure. So we got 27 volts there and 27 volts here. So everything is good. I'm going to go ahead and shut this off. So that's how it should be operating. You're going to have a higher pressure applied on the pressure switch than what the rating is. It's usually 2 to sometimes even 3 times as much. So right now, this is all good. Now you can take this right here and switch that with the one in the back. And so you want to make sure to test on both of these. So we could put this right in here and put this one back, and now we would be measuring directly on the inducer motor itself on this pressure switch in the back. So right here you see we're measuring 0.98 inches of water column, and so I can't get my multimeter to the back right here. You would have to disconnect these 2 screws, but anytime you're measuring a pressure switch, it has to be vertical. You don't want to set it on its side, so just be aware of that. So we've already covered number 33, which is the limit circuit fault right here with the flame rollout switch and the thermal limit switch. And then we have number 34, which is the ignition proving failure, which occurs basically up here, and the control board is sensing for the flame due to the flame rectification process. So we've already covered that. And then we have number 45, which is the control circuit lockout. And that has to do more with the circuit board, and that's after you have an abnormal flame proving when there should not be a call for heat. And basically that will auto reset after about an hour. But if that continues to occur and you don't measure a flame rectification signal, and your gas valve is closed and you don't have any other issues, and that error code will not go away, you may have a problem with the circuit board. But to clear that error, you would turn the power off and then turn it back on again. And so next, I just wanted to cover how to do a component test. Now, a component test is a pretty simple procedure, and that can be done down here on the test twin and the common. But basically what's going to happen here is the inducer motor is going to turn on, the hot surface igniter is going to turn cherry red, the blower motor is going to turn on at its lower fan speed in heat mode, and then also in cooling fan speed. So it's going to test out those 4 items, and it's going to do it for 15 seconds apiece. And so we typically are not doing this test that much out in the field, but I just wanted to show you how to do it. In order to do a component test, you cannot have a call for heat to turn on. So right now we're on the W and the C terminals, and we measure 0 volts. So that means the thermostat is not calling for heat to turn on. And also, when I do start the component test, you're going to see a error code status light of the last error that we may have had, which is likely going to be a number 12, which is a blower on after power up. So here you see your status code light. Then after that, the inducer motor is going to turn on. So that's it. It's as simple as that for the component test, but it's only testing your inducer motor, your hot surface igniter, and 2 to even possibly 3 blower speeds. And so there's a lot of other things that are occurring in a gas furnace, so you really need to know how to troubleshoot them. If you want to learn more about gas furnace operation and troubleshooting, make sure to check out some of the other videos we have linked down in the description section below, and also make sure to check out some of the articles we have over at acservicetech.com. We also have calculators, and we also have quizzes there. So make sure you check all that out, and also make sure to check out our books, the refrigerant charging and service procedures for air conditioning, and also the inverter mini split operation and service procedures. So they're available over at acservicetech.com and also on Amazon. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.